Sometimes unseen issues can be just as harmful as visible ones. This is true in plumbing too. Untreated acidic condensate from high-efficiency furnaces, boilers, and water heaters can silently corrode your plumbing system, leading to costly repairs and environmental damage. I'm Jeremiah Brody, and today I'll explain how condensate forms in a condensing unit and why it's important to neutralize it. Condensate forms when water changes from gas or vapor into a liquid. It is a byproduct of natural gas combustion when the flue gas temperature drops below 135 degrees Fahrenheit. 1 gallon of condensate is produced for every 100,000 BTUs of input in condensing units. This amount can add up significantly. On a cold day in a residential application, if a furnace operates for 18 hours, it can produce up to 18 gallons of condensate per day. In a commercial application, this can increase up to 260 gallons per day. To manage this liquid, you need to have a gravity drain or a pump to move it away. High-efficiency boilers, furnaces, and water heaters maximize energy efficiency by capturing additional heat from exhaust gases produced during combustion. They recycle this heat to preheat incoming water, making it quicker to boil if it's already at room temperature. These appliances have a secondary heat exchanger that cools exhaust gases enough to condense the water vapor within them, releasing additional heat energy in the process. Acidic condensate forms during the heat transfer process. To treat acidic condensate and improve quality of water, making it safe for various applications, we need to neutralize it. Neutralizing condensate is similar to neutralizing water in swimming pools, hot tubs, aquariums, or when watering plants. The process of neutralizing makes something ineffective and harmless. It's the reaction between the acid and a base. To neutralize water, we first need to understand the measure of acidity and basicity, also called alkalinity. Ranging from 0 to 14, a value below 7 indicates acidity. Lemon juice, for example, it's acidic. A value above 7 indicates alkalinity. Bleach, for example, is an alkaline. While neutralizing, the goal is to bring the pH level close to 7, or as neutral as possible. Failing to neutralize condensate can result in pipe and infrastructure deterioration, contamination of environment, and groundwater pollution. As the condensate progresses through the plumbing system and into the water cycle, it may eventually reach lakes, streams, and water that waters our plants and our drinking water. So how do we solve this issue? We neutralize the acid in the condensate with an alkaline mineral. That's where Franklin Electric's Little Giant line of condensate neutralizing products come into play. These solutions, which include an integrated condensate neutralizer media, help treat acidic condensate before it enters a plumbing system. To learn more, visit Franklin Tech and visit our product site, littlegiant.com, to view everything Little Giant has to offer. Thanks for watching.